Okay, so hello everyone. Welcome to the YouTube channel called Singerji, directed by Shubham Karmakar, and I'm welcoming you all to the course DSA using C. And it is our day 5, and we are talking about the singly linked list. The video in the last video we have told you what are the types of the linked list, and there are 4 types: singly linked list, singly circular linked list, doubly circular linked list, and doubly non-circular linked list. Means basically which are single linked list, circular linked list, doubly linked list, and doubly circular linked list. I think the case is clear. Don't make any mess in your mind. Start with a clear concept. Today's video is very long. It will be very long because the concept of linked list we are implementing here. All the operations, how the structure is created, we are talking about all. Okay, if you don't have idea about linked list, you can here also learn it. And it is the first video on the implementation of linked list, so it will be something long, but the next videos will be not so much long, because if you once understood how a linked list is created, the other varieties of the linked list you can create it by yourself only. So how is a singly linked list look like? So go to the browser. I'm not working too much as we have the opportunities to make it easy. So what is singly linked list? You already know, but still I have to show you. How is the singly linked list look like? I think this is good. We have a head variable. It is actually a pointer, head pointer. Then it points to the A, the first node. The next part of the first node points to the address of the second node. The next part of the second node address to a point of the third node, and the sequence goes on like that. Okay, and the last node, the next part of the last node points to the null. That's the simply singly linked list. Okay, so why it is singly? Because a single pointer variable is there, means data part takes the value, and one pointer variable is here, that is next. So it is singly, and it is basically non-circular because starts from a point and ends at a point. Okay, now how is the implementation? So before going to the implementation, you have to know about these two things: the structures and the pointers. What is a structure? Structure is a data type, user defined data type, you can say. Means a data type where, if you work in Java, Python and C++, you can create the objects. Here in the C language we have not any objects, so the linked lists are created using the structures and pointers. Structures is a user defined data structure where many type of datas, varieties of datas and data types we are collecting in one variable or one data type. That is, structure and pointers is the variable which points to the address of another variable. It is the basic thing. If you want to, if you don't know at the deep of these concepts, please read the concepts previously, because these concepts are very much important to understand you the concept of linked list implementation. Okay, so I think you have done the learning of structures and pointers, so we can go to the implementation part. I have opened VS Code, and I think that's very much fine. Look, I have already written the code because I don't want to waste the time. We are directly jumping to the implementation discussion, how it is implemented. So let me copy this image and paste it. I want to show you some practical things. Okay, so what is actually happening here? Okay, we will see that. Okay, so that's our linked list, singly linked list. Okay, now at first go to the code. It is too much big, no? Okay, I think that's enough. We have two libraries, standard input output library and stdlib library. That's the basic things. We are creating a struct node, means a structure. Naming node, the type is struct type, the name of the data type is node. What is in the data type node? There is a integer variable that is called data and a struct node type that is the pointer next. What is these things? Every node has two parts. One is data part, means it is the simple integer part, and the next part is the pointer that points to the next variables next node's address. So that is struct node next. It is addressing to the whole node, so it is the type of struct node. The structure is created. Now we will have some function declaration, that is struct node create list, struct node insert at beginning. What are the things I am telling you? Create list means we are at the first we are creating a linked list, and we pass the struct node head. What is head? Head is the pointer that points to the first node. Okay, now what's the next? We are passing the address of the head node, and it helps to access the whole node. How? If we can give the address of the head, it accesses A, B, C and sequentially D to the last node also. Okay, now struct node create list means after the creation we will return some value, and that value will be type of struct node. What will be the value? Basically we are returning the head pointer itself, because we have to access the whole linked list. Now insert at beginning means inserting a node at the beginning, insert at end, insert at position means inserting a node in a specific position of the linked list. Okay, how it works we will discuss later. Delete at beginning, delete at end, delete at position. Okay, now is the update node, means updating a value of any node. Suppose here in A we have the value of the node 3 and we want to update it by 2. So here we use the update node. It has no return type because we don't have to return the whole thing. Okay, void display simply displays all the members of the linked list and count nodes. How many nodes are in the linked list we are counting here. Okay, now we are creating a main function, and in the main function the struct node head equals to null. At the beginning, very beginning, we are considering the head equals to null, means the linked list is empty totally. Okay, now in choice is the variable that takes our choice. What are the choices? While 1 means it runs infinitely till we are exiting. Okay, what is that? Create linked list, insert at beginning, insert at end. The options we have given, that is the things we are told you at first. What is the choice of ours? What we want to do? All these points are one-on-one operations. Creating linked list, inserting at beginning, deleting at end, counting, all are the operations we can do on a linked list. Okay, now we take the choice and as our choice we do something. Look, I have told you now that, so see here, create list takes head and returns the value in the head. Insert at beginning, insert at end, that I have told to you why it is struct node type. Okay, now insert at end, insert at position, delete at beginning, delete at end, delete at position. Okay, but in the case of update node, we are not returning anything. Display, we are not doing. We are simply calling the functions and breaking. How the function works, we will discuss it later. Okay, in the option 11, we have the option exit. So we print a exiting program and returning it. And by default, invalid choice means if any of these choices are not taken, so it will be an invalid choice. That's and at last return 0 means our function has been completed. Now we are entering into the main logic part. What is the logic part here? Okay, so what is in the logic part? Think, let's take a deep breath and enter into a logic. Okay, you have to know, you have to understand. Anyhow, you have to understand it. Okay, let's see. We have a struct node create list. How it is working, we are taking. I think you are clear that head is a pointer, so we are giving it, taking it as pointer, and the return type is struct node, but we are returning the head, so we are taking it the pointer. How the pointer works, if we don't use this at this way, how we use double pointers, what are the things, you have to know it. So clear your concepts of pointers and structures clearly, then please come here. Okay, otherwise you will not understand, and without using structures and pointers we cannot implement linked list. And array is okay, but linked list helps to implement all the types of data structures itself. Okay, so you have to know the structures and pointers at basic. Now don't do very much mess. N is the number, I is the position, and the data. These are the basic things. You don't have to know these things. Go to logic. Head. If head is not equals to null, means head equals to null means there is nothing. Head not equals to null means here is something. Something is here. Okay. If something is here, why we have to create the list? So we are in the create list function. Okay, linked list is already exists. If you want to create a new list, then delete the existing. That's the first point. And if head equals to null, then we will execute this part. Okay, what we will execute? At first we will take the number of nodes, how many nodes we want to insert at the beginning of the creation of the list. Okay, now if n less than equals to 0, must be greater than 0, and the number should be, that's we have told here. And otherwise I equals to 1 goes to I less than equals to n, means for every position. For 1 we are doing something, then 2 we are doing something. What? The first line, it is the most important line. Please check it clearly and with focus. New node equals to, we are taking a variable, what we will discuss later. We are allocating memory at the memory space. What is that? Struct node malloc, memory allocation we are doing of the type struct node. And what will be the size of the memory? Of the size a struct node takes. Okay, the memory we are creating for one node here, and giving the new node the access of the memory. Is it clear? Otherwise repeat it and check it. Okay, the next, if new node equals to null, means the memory allocation is failed. Return kar do. If otherwise, enter the data for the node percentile d comma I, means if we are in first iteration, enter data for the node 1, in second iteration enter data for the node 2. These types we are taking the data and make the new node data as data, means the data should be allocated at the data part of the new node. How it is working? If we have a blank page, okay, we are making a simply a node, and it is the new node we are calling. We have given the data, suppose we have given the data 1 is allocated at the data part of the new node, and the next part have the null, means we are not showing what address we are giving to the next part of the new node, so we are declaring it as null. Is it clear? Then if head equals to null, already if head equals to null, mean the address is empty, the head is empty, the linked list is empty, means it is the first inserting at the time of creating the list. So head equals to new node. New node will be the head. It's clear, I think. Else, temp equals to head, means suppose we have already entered the A. We are not entering other things. We are simply entering the A only now. Okay. So we have entered the A, nothing else. So what will be the thing? Temp equals to head, means we are taking it as temp. I am writing T only. Now while temp dot next is not equals to null, temp equals to temp dot next, means we are going to the next node. Temp equals to temp dot null. I am telling the arrow as null dot. So temp equals to temp dot null, means we are going to the next node until. Now see, when it is temp and temp dot next, here is nothing, means here is null, and when it is null, means it is the last node. Am I clear? I am telling you, if you are unable to understand my concepts, please rewind the video and check it. Okay. Now it is the last node, means we have to enter the new node after the last node. Is it clear? Now then at the last moment we have gone to a last node, then the temp dot next equals to new node, means we are inserting the new node at the next part of the last node. That's the new node it is. Okay. Now it's the creation has been completed successfully, and we are returning the address of the head. So that is a very much clear thing. It should be very much clear. So do one thing, save the program. Save the program and run it once. Okay, I think it is very much important to run the program once. Using this. Okay, we have to do something. Yeah. Yes, it has been done. So we have the options create linked list. So we are at first creating it. Enter my choice. It is 1. Enter the number of nodes. Suppose 2 nodes we are entering. Node 1 we are giving 2. node 2 we are giving 3. Okay, the linked list has been created successfully. Now see one thing. At this position we have 2 and 3. Okay, at first discuss all the things, then we are giving an example. Okay, basically it is like that at this point, 2 and 3. Okay, now check it once. What are the next things? Insert at beginning. Insert at beginning means we are inserting the variable at the very much beginning. So let's clear that part and start from the start. Okay, now just if we want to insert a node at the very much beginning, suppose we have created one node named new node, and we are creating the node with giving the value of the node, which value we want to enter here, and then what we have to do, we have to give the address of the a to the next part of the new node and make the new node as the head. Nothing else is required. So automatically this relation will be cancelled and it will be the head node. The new node will be the head node. This one, it will be the head node. So here we don't have to think about it. But one thing you have to remember, that will be helping you always. Every time you are inserting or deleting one node, make sure the addressing part have to be completed at the first. Means the next of the new node should be addressed to the address of the first node previously. Then we have to make it the head. If at first we make it the head, how we can access the first node? Means the first node, it was in the very much first. A is the first node now. So if I address the head to the new node, how will access the A? So at first, using the address of A, using the address of head, we can access the address of A at the first. So we can say new node dot next equals to head. We can access it by that. Then we are creating the new node as head. It is inserted at beginning in this way. Okay, so here is nothing in the logic. We are allocating memory. If new node is null, memory allocation failed. Data we are taking, then new node dot data takes the value of data. New node dot next takes the address of head. I have told you that thing only till now. Okay, then at last we are making the new node as head, and we have printed that we have inserted at beginning successfully. Okay, now if we are inserting at end, what we have to do? Let's see. Don't worry, let's see only. Okay, how we can do that. So for inserting at the last, we are taking the first head variable as temp. Temp is the head. Then we are checking using temp equals to temp dot next. Means going to from here to here to here to here, from here to here until the last node is found. Then we are adding the node at the last node. How? Nothing. While creating the node, we have given the next part as null already, and here we have given the value. Simply the previous last node, the last node that was the last node at the previous stage, make the next part of that node given the address of the new node. That's the only work. If you have not understand, please rewind. Struct node, insert, and what you have taken, allocated in the memory. Now entering data we are inserting at new node data, and null we are inserting at the next part of the new node. If head equals to null, head equals to new node is simply, or you can call the insert at beginning, means if there is nothing, we can simply insert one node. That's the thing, nothing is there. Then if it is not, then we are making the head as temp. While temp dot next not equals to null, we are incrementing the temp. How? At this point, temp at C, the temp dot next not equals to null, but the D, the temp is equals to null. So until that we go to the last node, we are traversing from here to here, from here to here, from here to here. As we have reached the last node, what is the logic? Temp dot next equals to new node. Means at the next part of the last node, we are giving the address of the new node. And the new node is already been ready to be the last node because it has the value and it have the null in the next part. So our operation is completed. Not understood? Please rewind it and check it again. Okay, I think it should be clear. Now, what is insert at specific position? Here it is the main logic part. Here it is the main logic part. Please look it at clearly, very clearly. Now, insert at position means we have to insert the specific node or the specific value at the specific position. How it is working. So please check it very much clear manner. Now we have, suppose we have this node only, this linked list. It is our linked list. So what is the addresses or positions? This is 1, this is 2, this is 3, and this is 4. If we have to insert a new node at position 3, where we have to enter it? Think. If it is the new node, so where we have to insert it? We have to make it at the position 3. So where we have to insert it? Here or here? Think. If you have chosen here, so you are wrong, because when it will be entered here, it is already 3, the position will be 4. So we have to insert it here, because after 2 it will be 3. This position will be 3, it will be 4, and it will be 5. Okay, I think it is clear. Now just let me clear everything here. Okay, now suppose it is the new node. So what we have to do? We have to make two variables. One will be the temp. I think here we have to make one variable only. Just let me check. Yeah, here we have to make only one variable. Two variables is required in the case of deletion. Okay, one variable temp. Okay, it will be temp. We are incrementing temp. You know how to increment. It is temp. Now we are going to the position. Position is 3 here, where we have to insert. So we are going to the position minus 1, means 2. Then we have told you, work with the new node's address first. The address of the new node dot next will be temp dot next. The address of the new node dot next will be temp dot next, and the address of the temp dot next will be updated as new node. Is it clear? The thing is that only. New node takes the data. We are not giving the next part because it will not be null. Now temp equals to head until we are getting to the position -1, we are incrementing. Now here less than position -1, not less than equals to position -1, means position -1 is 2 and less than position -1 is, it is satisfying until 1, but when it is satisfied, till then it is incrementing by 1 place. So actually we are at this point at present. Now if temp equals to null, if this point is null, if 2 is null, how can we insert in the 3? It is impossible, so the position does not exist. Free the new node. If all thing is okay, then new node dot next we have to make temp dot next. I have told you that the next part should be done previously. So new node dot next equals to temp dot next. Temp dot next is already in C. So new node dot next is temp dot next, and then temp dot next is the new node. New node equals to, means temp dot next equals to new node, means we are making the temp dot next position, giving the address new node, and the node is inserted at position successfully. This all are the insertion operations, and I think these points are very much clear to you. Now we are going to the deletion operations. Deletion is quite not too much difficult, but let's see. Okay, if we want to delete at beginning, what we have to do? We have to delete this. Take in mind why we are deleting. When we are deleting, suppose we are deleting A, so we want to delete the memory of A also, means the memory should be freed. If the memory is congested, what is the profit with the deletion? There is no profit, and memory will be gradually increased always. So when we are deleting, we have to delete the memory also, we have to free the memory also. So for freeing the memory, what we have to do? Let's check. If we want to delete A, we have to do nothing. Make the B as the head. A will be obviously A will be listed out from the linked list. Okay, but we have to take the address of A. Take a temp variable to take the address of the head previously, so we can take the address of A, and later we will free the space. The space of T will be freed. Okay, then we will complete our deletion. I think it is understood very much clearly. If head equals to null, list is empty, no deletion required. Otherwise, temp equals to head, we are taking the head address, then we are making the head to the head dot next, means it was the head, so head dot next means this part, and we are making this head, and later we are freeing the temp because we have already declared as temp. So we are freeing the temp, means we are freeing this space. Our deletion is completed. I think the point is very much clearer to you. What is for the delete at end? Nothing. What do we have to do? Please make a fresh image. Always start with a fresh idea, then the understanding will be very much clear to you. Okay, now while deleting the end, what do we have to do? Obviously, C dot next will be null. C dot next will be directly null. We're not making this as jumping that one, but means okay. So here something other concept. Please stop the video for a while and think about the drawback. Means as we have done in all the things, all the operations, what will be the exception here? If we do not use any exception, it will be a drawback. Think about it. Okay, if you have thought, let's check it. Now, see, if we make C dot next equals to null, how can we access the address of D? Because we are making temp dot next, temp dot next, temp dot next. But we have at C right now, we have not reached to the D. So how can we free the space of D? Here we have to take two variables. The C will be the previous and the temp will go to the here. How it is working? How it is working? Please check the code. It will be clearer to you. If head equals to null, it is not required. Otherwise, head dot next equals to null means head is not null. There is at least one element. And head dot next equals to null means there is only one element. So free the head and head is become null. The linked list is empty. Not thinking about large about it. Now to come to our point. Temp equals to head. It is very much known to us. And one more thing is taken is previous equals to null. How? How? Thinking about it. Thinking about it. Now, while temp dot next not equals to null, previous equals to temp and temp equals to temp dot next. What is the thing? What is the thing? We are doing it is temp until at the next part of this temp is null, we are updating the temp. So temp is updated here, but we are telling that before updating we are making the temp at the last step as previous. As previous, we have told only this thing. See, until temp dot next is not equals to null, previous equals to temp, and then only temp equals to temp dot next. Okay, so it is previous and it is temp. Now it is updated again, it is temp, it is previous, updated again, it is temp, it is previous, and we are not updating after this step because temp dot next is null. Okay, now at this position the temp is the last node, okay, and the previous is the previous node of the last node or the second last node. What we have to do, previous dot next equals to null means next part of the C will be null. That is done, and we have to free the D means free the temp. Very much easy. Not have to think about it more. Okay, now struct node delete position. Okay, how to delete it at a specific position. Suppose, let's clear it again and then we will go to the explanation. How? Question is how. Suppose this is the point 1, 2, 3, 4 and we have to delete the number 3. We have to delete the number 3. How we can delete? Taking the address of this and making the next of this as this. Nothing is required again. Nothing is required. How can we do that? You can simply understand now. head equals to null, taking the position less than equals to 0 means invalid, that are the things. Position equals to 1 means delete at beginning, very much clear. Otherwise temp and previous we are taking as the same. You can understood na how we are doing this. It is the previous node here and it should be a temp. If you understood these things, that it should be the previous and it should be the temp, means you have understood half of the things. Okay, now see how it is working. From I equals to 1 to I less than positions, mean to position minus 1 to here. What we are doing? And temp not equals to null until it is null. If it is null, the execution will be cancelled. That will not make any sense. Until then, previous and temp, how we are working, it will be the previous and it will be the temp. For I equals to 1, we are here to here, temp will go. I equals to 2 here to here. Now we have working for less than position, means less than 3, means to the 2, means we are iterating 2 times. I equals to 2 we are going. So at that position it will be the previous and it will be the temp. You can dry run and you can check again. If temp equals to null, position does not exist. Otherwise previous dot next it will be, the previous is B, previous dot next will be temp dot next. Temp dot next means D. So the next part of the B will be addressing to the D. And free the temp means free the C. Okay, nothing is required again. Okay, our deletion operation is also completed. You have reached to a very big milestone. Now some small things are here, we are checking it. Here we have the operation update node. What is updating a node? Updating a value of a specific node. Means suppose we are given that update the value of the node of at position 3, means it is 1 2 3 4. Then update the value of the node at position 3, means position 3 should be updated, means the value of the node at the position 3 should be updated. How it is working? Head equals to null means the linked list is empty, otherwise take the position less than equals to 0 means invalid, temp equals to head. That's the basic things. We will go to the position. How? Less than position we will run the code. So less than position means here. Suppose we have to update the number 3, we are going to until number 2, and position 2 it is running again, and less than position means at position 2 we are running the code. Temp equals to temp dot next means it automatically goes to here, and it is the temp now. It is the temp. What we have to do? If temp equals to null, position does not exist. Otherwise, current value we are showing temp dot data, and then we will take the new value, and new value should be updated to the data part of the temp. Yes, completed. We will simply take the value and put it here. Nothing is doing with that again. Okay, so the update is completed. Now the next operation, that will be the display linked list. How we have to display? Simple. Start with the head node. Okay, taking it temp and temp dot next and displaying every variable one by one. That's fine, nothing. How? Head equals to null, linked list empty, otherwise temp equals to head. Now, while temp dot next, it is not, it should be temp not equal to null. Means we are not checking to the next node. We are checking if that specific node is null or not. Because at every position, we have to print the value of that position only. Okay. If temp not equals to null, we have to print temp dot data. Means at first we are printing that it is A. So print the A. Okay. Now check what we are doing. If temp dot next is not equals to null, then print the arrow. So temp dot next is not equals to null, so arrow printed. If temp dot next equals to null, what we have to do? Means it is the last node, so we don't have to draw an arrow for that. Clear? Okay. Now temp equals to temp dot next, means we are incrementing. Temp is gone from here to here. Okay. In this way we are running, and at last when we have gone to the last node, means temp dot null equals to temp is null, then print arrow null, means A, then B, then C, then D. We have reached to the last node, and now print the arrow null for showing that it is the last node. I think this part is clear also. At last, how to count the number of nodes. How? We will take the first node as temp. Count will be at first 0 while we are traversing temp to the next node, to the next node, to the next node. Then we are incrementing count. Sorry for interruption. Okay. Now, where we're going. So we're counting and incrementing the count. Temp goes to here and count is incremented by once again, count plus plus, like this. Okay. In this way we are implementing whole thing and the count is incremented. So I think that's not too much difficult. Count equals to 0, temp equals to head, while temp not equals to null, count plus plus first, then temp equals to temp dot next. Okay, and at last we are returning the count. Now we don't have to run a loop for counting every time. How we can do that? While we are deleting a node, we can at first we can make the count variable as global, and while we are deleting a node, we can make count minus minus here, count minus minus. Okay, so the work of us has been decreased, and at the time of insertion we are doing count plus plus, so we don't have to run a loop again for count variable. Clear? I think so. That's very much easy thing here. Now please take an example. I think that should be very much good to take an example. Where is our terminal? Where, Babu? Where you have gone? Our terminal. Yes. So 2 and 3 are created. So let's check. we will discuss using the dry run. Now we have created 2 then 2 then 3. Okay, now we are inserting at beginning, so number 2 is our choice. Insert at beginning, enter data. Suppose we are inserting 5. Node inserted at beginning. Okay, that's fine. So how will it look? It will look like 5 2 3. Now insert at end we are doing. Suppose we are doing 4. Insert at end is 3 and we are inserting 4. So it should be look like this, and then we are inserting at specific position. So suppose we are inserting at specific position, means the choice is 4, and we are inserting 6 at 6 position. Data is 2. What we have written, position does not exist, because here is no 6th position. 1 2 3 4, there is no 6th position. How can we enter? That's fine, very much fine, but we have to insert. So if we insert at the position 4, means this is 1, this is 2, this is 3, and we want to enter here, it will be 4 and the 4 will be at position 5. If we can do that, we can. Now so insert at specific position, our choice is 4. We are inserting a position 4 and the data will be suppose 6. So inserted, so it should look like something 3 then 6 then 4. So once display the list, 9 5 2 3 6 4, then null 5 2 3 6 4, and obviously after that it will be null. Now delete from beginning, though, so the code is 5, no deleted from beginning. So it should look like this. Okay, now the number of elements, number of nodes are 4, so once count the nodes, count equals to 10, so 4. Okay, that's fine. Now delete from end. 4 we have to delete, so delete from end, and the code is 6, choice is 6. We have deleted from end. Then delete from specific position, so 7. Node position, which we want to delete, 2 3 6, 1 2 3, want to delete the position 2. Okay, so position is 2, deleted. So what should be the linked list look like now? 2 and 6, it should look like 2 and 6. Okay, so let's display once 2 and 6. Okay, now update a node. How to update? Suppose we want to update 2 as 3. Okay, so how we can do that? Update a node, so choice is 8. Position to update, 2 is at the position 1, so 1. Current value is 2, we have it has been displayed, and we want to enter the new value as 3. Now please display it once. Look, 3 6 null. So all the things are working very fine, very fine. We have showed you how to implement the singly linked list. Now this lecture has been gone very much long. Acha, okay. Now exit the program. Program exited. Okay. Now the whole thing is very much clear to you, and the singly linked list has been done. After that, the doubly linked list, circular linked list, doubly circular linked list will be very much easy to you. Okay, we don't have to give too much time to that. If we want, we can also give the code of some linked lists, and you can also see that. I will give it to you. Please, please, please see, it is the WhatsApp channel, Shubham Karmakar. Okay, you can get all the notes from here. You can get all the notes from here. So please follow this channel. Okay, I have given you the screenshot only. So please follow this channel, and you can get all the codes and notes, all things. Okay, so nothing to tell about more. Please stay tuned, keep learning, and bye bye. See you in the next video.